Hello. In a recent video, which I believe was on collecting like terms, which you can find as part of the Foundations playlist, I introduced the notion of the distributive property. However, I did not go into any details about the distributive property, why it works, its underlying or key intuition. I just sort of left it as a really basic, crude introduction. So I thought in this video I'd spend a few minutes just quickly going over the distributive rule, as it is quite an important one as one begins working in algebra. So say for instance we have, or I'll write it out first, so it's a distributive property or rule. Okay, say for instance we have A times B plus C, which is the same example I gave in the previous video, okay, where A is the coefficient, so I'll just underline that. A is the coefficient of the expression in the brackets, which in this case is B plus C, okay? What the distributive rule states is that we can expand this, okay, using the distributive property. We can expand this out where A would be A times B, whoops, write that a little bit more neat, A times C. Okay, so A times B would be AB, and that would be plus A times C, which is AC, so plus AC. So in short and very simple terms, what the distributive property states is that we must multiply the coefficient, in this case A, by each term within the brackets. Okay, and then we can add and simplify. So in this case that would equal AB plus AC. To give a deeper sense of what's going on here, or another example, perhaps I'll use a geometric illustration. Okay, so let's use my drawing tool here. I try to draw this as neat as possible. I quite like this software. I use it a lot for physics, just drawing different diagrams and things like that. So say we have two small rectangles, I don't know, something like that, okay? And we'll call this side A, the base here, we'll call that B, and we'll call this C. And then down here, give you a sense of things, I'll try to draw this again as neat as possible. We can call this part, here we can say this is B plus C, right? This is this entire length of this side, that's B plus C, as we see up here, right? B, this section plus this section, C, B plus C. Okay, so the overall area of this larger rectangle, the overall area, A, is going to equal A times B plus C. Alright, which would be length times width. A equals length times width, right? Area A equals length times width. So in this case, length times width, A times B plus C. Okay? I mean, we could also actually, we could add the two areas together of the rectangle. So in this case, so A times B. So here, maybe I'll use it in a color. Okay, A times B. So area A for this smaller rectangle would be A times B. A times B. Okay, and that would be the area here. And then if I use this, switch colors, use magenta for this one. So then for this smaller rectangle will be area A equals A times C, right? Length times width, A times C, and that's going to give us this area right here. And then we can essentially add these two areas. Okay, and so in this case, area A would equal A times B is AB, A times C, as we saw up here, is AC, so it's going to be AB plus AC. So, well, this is, I suppose, a bit of a silly proof. We could equate these areas, right? Okay, because we found that the area is A times B plus C, and here we found that the area is AB plus AC. So therefore, AB plus C equals AB plus I'll write that a little bit neater, AC, right? Just as we found up top. So all the distributive property is saying is that, again, is that we must multiply this coefficient by each term within the brackets. And this is a very important rule in future videos, especially when you get into algebraic expansion and things like that. I might start with a very simple video on basic algebraic expansion before getting into much more complicated expressions. The distributive property is quite fundamental. It's something that we're going to use all the time, quite often, and so yeah, but I'll save further discussion on those points for later.